All right, here we go. So we're going to take a look at lesson 4 now. So lesson 4 has to do with solving equations. We have a couple different types of equations we're going to solve. So let's take a look. So starting right off at the top here, it says an equation is a mathematical statement that two expressions are equal. So for example, 7y equals 4. Another example is 3x minus 2 equals 8x plus 1. Those are both equations. So the main thing with our equations here, right, is we have expressions, but we have that they're equal to each other. So all equations have an equal sign. Make sure you have your equal signs in your equations. So it continues to say that many real-life situations can be represented by equations. To write an equation to model a real-life situation, you need to translate a verbal description into mathematical expressions that are set equal to each other. So what this is saying is if you have a real life situation, when we say translate a verbal situation or translate a verbal description, right, we're saying that we want to take words and turn them into numbers, variables, and operations. So the first example of translating a question here is take a look at sample 1. It says that a tree was 4 feet tall when it was planted. It grows 2 feet a year. Which equation could be solved to find how many years the tree will take to grow a height of 16 feet from the time it was planted here? So if we go through, we want to highlight our important information. So we know that the tree was 4 feet tall when it was planted. Okay, it grows 2 feet a year. And then we want to find out how long it will take to be 16 feet from the time it was planted there. So when we see 2 feet a year, right, and we also want to find how many years we're looking for, we know that our variable is going to be years. So when we see 2 feet a year, we also know that this is going to be 2 feet a year if we want to find out how many years we have here. Now, we know that it started at 4, so however many years it is, it goes 2 feet per year, but we always add from where it started, which was 4. And then we want to find out when this is going to be equal to 16 feet here. So we're looking for this equation here, which is choice B. Now, one of the keys is once you find your variable, which was years, right, we want to find the rate at which those years change. That's where we get our 2y from there. And that's something that's kind of important and kind of gives away for the rest of these choices here, right? Because we don't want to multiply 4y because each year does not grow 4 feet. Right? We don't want to take y multiplied by 16 here or just add y. We need y to be something that is multiplied by 2 feet. So it says here that in this situation, the unknown value is the number of years it will take the tree to reach 16 feet from the time it was planted. Assign the variable y to the unknown. Each year, the tree grows 2 feet or 2y. Since the tree was already 4 feet tall when it was planted, add 4. The expression 2y plus 4 represents the height after y years, and then we set that equal to 16 for 16 equals 2y plus 4. So that's a quick overview of translating verbal description into mathematical expressions. That's probably one of the more difficult things that we're going to be doing in this lesson here, so make sure you ask questions through Schoology if you have any as you're going through on your own for some of the sample problems or practice problems at the end. All right, so now we get into just linear equations. So now we're talking about a specific type of equation, which is a linear equation. So real-world patterns and relationships are often modeled by linear equations and represented as straight lines on a graph. A linear equation, it's a nice definition here, is any equation that includes constants and variables that are multiplied by coefficients. So a lot of words here that you need to pay attention to here. So if you take a look on the right here, right, you have constant, variable, coefficient. Very important to know each one of those here. So when we're taking a look at the coefficient, coefficient is our number in front of a variable, the number that is multiplied with that variable there. Then we have our variable, right? So the variable is our unknown number, and then our constant was our number that doesn't change here. That's our constant. We're going to be referring to those a lot as we go through here by name, so make sure you're aware of which is which, and you might want to write those down somewhere else just to make sure you're comfortable with the vocabulary. So here it gives us 3 examples of linear equations. So all 3 of these are examples of linear equations. Then things that are not examples, right? Here's a couple non-examples here. One, we have a square root sign. That's going to make it so it's not a linear equation. Here, our absolute value sign. That is a different type of equation there. And then finally, our x squared, right, will give us a different type of equation as well. All right, so taking a look on page 27. Starting at the top here, we're talking about solving linear equations. So to solve a linear equation, you need to write it as an equivalent equation with just the variable on the left side. Rewrite the equation by adding, subtracting, multiplying, and dividing, and make sure you do the same operation to both sides of the equation. The properties you can use are shown below. So some of the properties that we'll be using here are the addition property of equality, the subtraction property of equality, multiplication property of equality, and division property of equality. And what that means is that if you add something to both sides of the equation, and you add that same number here, so if we added a to both sides, that a doesn't change, it's still equal. So we're going to take a look at solving some equations here. So for example, here's how to solve the equation 2x minus 12 equals 10 for the variable x. So if we take a look, they're explaining what they're doing each time here so that you can see it as they go through. So they started by adding 12 to both sides of the equation. So you can see they added 12 here and they also added 12 there. So remember, using the addition property of equality, that means that it doesn't change the equation. It doesn't change the state of it being equal here. So now they added 12 to both sides because we wanted to get rid of this constant over here, this negative 12. So we did the opposite of 12, which was to add 12. These two, negative 12 and positive 12, simplified down to 2x here. And then 2x, 10 plus 12 equals 22. So the second step of simplifying there. Then, if we want to get x by itself, we need to get rid of the coefficient, right, which is 2. So we divide both sides by 2. And that's where they get, so we're dividing both sides by 2, that's where they get x is equal to 11 here. Now when we write it horizontally like that, often we're not used to seeing it that way. So I'm going to write it up here, maybe the way that we're used to seeing it in class. So if we have 2x, is it minus 12, is equal to 10. So here we take a look. If we want to get our variable by itself, first we got to find the variable, right? So we have our x here. We know that we want to get x by itself. What we do is we have to get rid of everything that's over there with that x. We always start by looking for addition, subtraction. In this case here, we see that we're subtracting 12 from this 2x. So we want to do the inverse operation of subtraction, which is addition, and do plus 12 plus 12. Then we simplify. 2x comes down. We have our equal sign. You can draw your line down here. 10 plus 12, which is 22. And then again, we take a look at what's still with this x here, which is that 2. And the operation that's happening there is this is 2 times x. So we want to do the inverse of multiplication, which is division, and divide both sides by 2. Divide by 2. 2 divided by 2, it just leaves us with 1x, which is still equal to 22 divided by 2 is 11. So in this case here, we have x equal to 11. So this might be a more familiar way that you see when we go down vertically here as opposed to the horizontal way shown in that book there. All right, this next little statement here just talks about how we write our solution. So one way to write it would be x equals 11, right? The possible solution set for an equation can be represented as a solution set of the equation. Set notation uses brace symbols. So we've seen it where we might put our answer in brace symbols there, and is used to denote the solution set of an equation. Solutions to equations can also be represented as points on a number line. So if we took a look here, we can also take a look. This 11, right, could have been a point on a number line. We could have had a number line here and say, let's say 9, 10, 11, 12, we could have plotted our solution there at 11 as well. So that's all they're doing here. In this question here, it says 3x plus 1 equals negative 23, and it wants us to show the solution set on a graph below. So I'm going to write it over here. 3x plus 1 equals negative 23, and solve it how we would do it in class. So we want to get we want to get x by itself. So first we have to get rid of this positive 1 that's with it. So we're going to subtract 1 from both sides. Subtract 1. And here we could have our line coming down. So 3x comes down. Positive 1 minus 1 is 0, which is good. We wanted to get rid of that. Then negative 23 minus 1 is going to be negative 24. Then we continue to go through here. Now we have 3 multiplied by x, so we want to do the opposite of multiplication, which is division. So we'll divide by our coefficient, which is 3, and divide this side by that same number because we have to use the division property of equality. 3 divided by 3 is going to give us 1x, and that's going to be equal to negative 24 divided by 3 is negative 8. So we look at our choices here. Choice A, right, has a dot at negative 8, showing that's the answer here. If we look at choice B, it's at negative 6. Choice C is at negative 6 and positive 6. And then choice D is at negative 6 and positive 8, all which are not part of the solution set here. So as we keep going along here, let's go to this section up here. So let me just organize my papers a second, sorry. So the original equation, or sorry, let's skip that part there because we just did that there. So it says often an equation needs to be simplified before it can be solved. So use the properties of numbers and the order of operations to write an equivalent equation. To simplify an equation, you may need to 1. Remove parentheses with the distributive property. 2. Collect like terms with the associative or commutative properties. And 3. Isolate the variable on one side of the equation using properties of equality. So now we're going to take a look and see what value of x makes the equation below true. So I'm going to work this one out separately. You could take a look at how they went through it, and the explanations they gave are all correct here, but I just want to show you as it's happening what we're doing. So when we take a look at this equation here, we have 4x minus 3, parentheses 3x minus 5 equals 2x plus 11. So the first thing we want to do is remove the parentheses. So if we have this minus side outside of our parentheses here, it's really like saying it's multiplying by negative 1. So what we can do is kind of what we did earlier, where we change this to addition and then change each of these signs here. So instead of positive 3x, it'll be negative 3x. Then we'll have plus 5 there, right? So if we change the subtraction to addition and then change each sign inside. So then we're going to rewrite this as 4x plus, negative 3x plus 5 equals 2x plus 11. So now we go through here and we have to combine like terms. So our like terms here are going to be our 4x minus 3x. 4x minus 3x is going to be 1x. So we just have 1x plus 5 equals to 2x plus 11. Now at this point we need to get all of our variables over to one side. So at the beginning I know it did say to move all your variables over to the left, but in this case here it doesn't matter what side we move it to. I tend to want to move the variables over to the side that has the larger coefficient. So our two coefficients for our variable x are 1 and 2. We want to get rid of this 1x because that will keep it positive when we subtract from both sides here. So what we're going to do is subtract 1x from this side here. And again, remember we have our line of equality here. Then minus 1x from that side there. Because what we do to one side, we have to do to the other. These x's will turn to a 0. So we'll just be left with 5 on the left side equals 2 minus 1x is going to be 1x plus 11. So now we want to get x by itself, so we got to get rid of that positive 11. So we're going to subtract 11 from both sides. And then 5 minus 11 is going to be negative 6 is equal to 1x here, or just x. So, and because our positive 11, negative 11 cancel. This one had a lot of steps, right? It started with removing our parentheses. So we removed our parentheses by using the properties that we learned when we were looking in lesson 3 there, where we change our subtraction of polynomials, right, to addition of the opposite. Then we collected our like terms here. Then we had to go through and move the variables over to one side of the equation and our constants over to the other side till we finally got to our answer here where x is equal to negative 6. And if you take a look how they did it here, so some of their explanation is a little bit different, but they're saying the same things, just a little bit more precise language. So it is important to read through here where it says distribute the negative 1 to eliminate our parentheses, right? So that was when we changed our subtraction to addition and then added the opposite of each of those terms there. Combine like terms, subtract x from both sides and 11 from both sides. And they get that x is equal to negative 6, which is the same as what we got here. Now we take a look at the next type of problems you might need to do. We might not be solving and just for a number here. So sometimes we want to solve equations in terms of a variable, which means we have an equation that has more than one variable in it, and we want to isolate one of the variables while still keeping the other variables in the equation. So sometimes equations are not solved for specific values of the variable. Instead, they are solved in terms of a specified variable. So to solve an equation for a specified variable, follow the same steps used for solving linear equations for the value of a variable. So this one here says that we want to solve the equation shown below for p. So if we want to solve for p, what that means is we want to get p all by itself. So p equals 2, and then we're going to have an expression that still has s's and r's in it and t's in it as well. So I'll go through how we do that on this whiteboard here. So we start with our expression, or sorry, our equation, which is s is equal to r divided by 2 multiplied by p plus t. Now let's move this up a little bit. All right, so first thing first is that we want to get rid of whatever we have inside of our parentheses here, or sorry, outside of our parentheses. So we have this r over 2. Now, one way that we can get rid of it is we can get rid of any fraction and turn it into 1 if we multiply both sides by the reciprocal of r over 2. So the reciprocal means that we're going to flip this r over 2 and multiply this side by 2 over r, and then this side as well by 2 over r. So when we multiply our left side here, we have 2 times s, which is 2s, divided by r is equal to. Now the reason we multiply by the reciprocal here is because we would have our 2's are going to turn into a 1 there, because 2 divided by 2 is 1, and r divided by r is also 1. So now we're just left with what was inside of our parentheses. 1 multiplied by this is going to leave it the same. So p plus t. So now, again, we said at the beginning that we wanted to get p by itself. So if we want to get p by itself, then we have to see what is with that p that we need to get rid of. Well, it's this t here. So what's happening between p and t is they're being added together. So if we want to remove it, we do the opposite of addition, which is subtraction. So minus t, and we subtract t from both sides. Now here, we're just going to rewrite this as 2s over r minus t equals to p. So we've gone through, we've isolated 3p, so it's all by itself. And if we take a look, that is the answer there. It's not pretty, but it is solved for p there. Now, the last type of equation that you're going to take a look at here is solving a exponential function. Let's come back in here. So, to solve an exponential equation, use properties of exponents, and as with linear equations, the solutions to exponential equations can be shown using set notation and can be expressed on a number line. So the example they give here is 4 to the x equals 32. Now, what we have to do is we have to rewrite each of these terms, so 4x and 32, with the same base. So the way that we're going to do that here is if we write over on the side here, 4 to the x equals 32. The first thing I would want to check and see is if 32, if there's any way I can use the base 4 to get 32. So I'd take out your calculator and I type that in there. So I type in, let's say 4 to the, then if I was starting here, I'd always start, 4 to the second power is 16. So that's not 32. But if we do, let's try 4 to the third power is 64. So since base 4 doesn't get us a 32, it means that we're going to have to change both of these sides here. So 4, the only other way we can write 4 would be is if we wrote it as 2 squared, right, with the base 2. Then also we still are multiplying by this x here. So 2 to the 2x. Now 32, if we have a base of 32, right, or sorry, a base of 2 here, and we take a look, right, 2, then we can go through some numbers here. So we know 2 times 2, right, to the second power is going to be 4. But if we put in here 2 to the fifth power, you'll see that it's equal to 32. So we can write that as 2 to the fifth power. Now, when we're here, our bases are the same. So what we can do is set our exponents equal to each other. So we can have 2x equals to 5. And then as you're going through here, we want to get x by itself. So we divide by 2, divide by 2, and x is going to be 5 divided by 2, which is 2.5 here. So again, we can write our answer as x equals 2.5, right? We can write it as the 2.5 in our brackets, or here they want you to choose the number line that has 2.5, which is choice B. So as you're going through the practice problems, again, 1 isn't too bad here, right? We're just solving this equation. 2, again, solving an equation, except for we have parentheses, so we have to use the distributive property here to get rid of our parentheses and then move our collect like terms, move our variable over to one side. Question 3, right? You're just looking at the different steps that they went through here. Then we have question 4. Question 4 has to do with translating a verbal expression here. And then finally, question 5 is our trickiest problem here, which is our exponents here. The nice thing is, though, that they used a base of 3. So we know that we can't rewrite this left side of the equation here. So you have to figure out how to rewrite 81 in terms of 3 to some sort of power there. 3 to some sort of power will be the same as 81, and you could set the exponents equal to each other. Going through here, question 6, again, 6 is just solving an equation here, but then they want you to graph it on a number line, so you can create your own number line here. Just put a couple numbers before and a couple numbers after, wherever you're graphing it there. 7, let's see, you're taking a look at this equation. She got an answer here. Explain why this answer is not correct. So think about when you put this answer in here, is there any way that when we're adding two positive numbers here that we can get to 0? And then solve the actual equation the right way here. And then finally, one of the trickier problems, again, is solving for m. So you have to think, how do I get rid of everything that's over here with this m? So the first thing you usually want to look at is this division here. So how can you get rid of that 3p? And then we can isolate m yourself there. So give those a shot. If you have questions, make sure to send messages on Schoology. We'll be checking them regularly and getting back to you if you have any questions. All right. Good luck. Keep working hard.